Hello, ladies and gentlemen. We have a numerical methods problem, and today we're talking about the simple fixed point iteration, and we have an example problem, so let's do it. So the problem says, approximate the root of f of x equals e to the x minus 5 plus x minus 2 using simple fixed point iteration, and we're going to be starting with an initial guess of 5, and they want us to obtain the first 4 data points using this method, and after we do that, we're going to finally plot these points on the graph below of g of x and h of x. So the two, important pieces of information here, they give us the function value and also the initial guess we're going to start with. And this is the plot below they're referring to of g of x and h of x. They're assuming that you're going to find g of x and h of x correctly. Alright, so let's get a separate piece of paper and do some of the calculations before we can actually plot the points. Alright, so our function, f of x, I'll rewrite that here, is e to the x minus 5 plus x minus 2. Okay, and for the simple fixed point iteration method, we will be finding the root, and that is where f of x equals 0, just to remind you. And the simple fixed point iteration method also separates the function into two parts, g of x minus h of x. Okay, and if you're not sure what these are, g of x will be our x value, and h of x will be the rest of the function. And how do you get h of x? You set f of x equal to 0 and then solve for x. So right here, setting f of x equal to 0, and we have 0 equals e to the x minus 5 plus x minus 2, and to solve for x, or isolate x, we'll want to subtract e to the x minus 5 from both sides and also add 2. So we get we get x equals negative e to the x minus 5 plus 2. And this right here is the rest of the function we were referring to. This is what h of x is equal to. H of x is equal to negative e to the x minus 5 plus 2. Okay, and if you watched the other video, I said that I like to write both g of x and h of x. I like to make two vertical columns, so let's do that. G of x is equal to x, and h of x we found to be negative e to the x minus 5 plus 2. And we're starting with the initial guess they gave us of x of I equals 5. So we're going to plug that into g of x. So g of 5 equals 5. So our first data point is 5, 5. Alright, and what we're going to do is we're going to substitute the result of g of x into h of x. So the output was 5, so h of 5, what does that equal? It's negative 1 plus 2, or h of 5 just equals 1. So that gives us our third data point, 5, 1. Our second data point. Oops, yep. And then the result of 1, we're going to plug back into g of x. So g of 1 is just 1, and that gives us our third data point, 1, 1. And to get our fourth and final data point, we'll plug the result. So g of 1 was 1, so we'll plug that result into h, and we will get 1.9817. And our fourth data point is 1, 1.9817. So now we can plot these 4 points on the graph that they provided to us. So let's go back to that graph right here. Okay, so the first point, this is the window is 0 to 5 to 5 for the x and y axis. So our first point is going to be in the top right. That's number 1, 5, 5. And our second point we found to be right here, number 2, and that was 5, 1. And our third point we found to be 1, 1, right, which is right here. And our fourth and final point that we'll be plotting was right here, which is 1, 1.9817. And another thing people often do is when they're going from one point to the next, they'll draw arrows to show that spiral-like motion. So going from the first to the second point, we have our arrow right here. And going from the second to the third point, we have our arrow right here. Going from the third to the fourth point, we have our arrow right there. And if we were to draw another arrow, it would be in that direction. So you can see you'll get a spiral-like motion, and the goal of this spiral-like motion is to eventually find the intersection of the g of x right there and h of x right here, and that intersection point right here is the root we're looking for, because whenever g of x and h of x are equal, then f of x equals 0 at that point, and that is where the root is located. And if you're curious, the location of the root, or that intersection point, is x equals 1.9525. So you can see our last value is 1.9817, and the actual value of the root is 1.9525. So with just 4 iterations, finding the first 4 points already gave us a pretty good approximation. All right, well, I hope this helped, and keep on keeping on.